Good afternoon to all. Today I'm going to discuss something about cloud computing, which is the subject which is for sixth semester as well as for eighth semester. For sixth semester, the curriculum was designed by a ISL engineering college, and last time what I told you of was totally different eighth semester syllabus. So this is the semester for this is the curriculum for eighth semester of historical development. All these topics which are available, we can able to go through this one. There is no issues cloud computing and other things. So for eighth semester, for eighth semester, these are the topic. Introduction, benefit, challenges, cloud computing services, cloud resources, resource visualization, which are the topics which are curriculum was designed by Matrushi Engineering College, and long time, 2 years back, they have developed this one. So this is what the next thing is that welcome aboard for eighth semester. This is the first time I'm going to handle the subject for eighth semester. There was a time that I could able to take the classes, but unfortunately I could not get the time, or the schedule was not matched, or the subject was not matched with me. And for the third, sixth semester, which I've already taken PL for them, now I'm going to take the next topic. This topic has been already been covered for sixth semester, but I'm going to repeat them. Uh, there are two classes for eighth semester, and there are four classes for six semesters. Monday, Tuesday will be combined for eighth semester, and the next two classes will be scheduled will be premiere on the different time for sixth semester. So you don't have to worry for the eighth semester. Now let's move on to the topic called what is cloud. For some, if you say take it into consideration, cloud is something which I can call it as a cluster, as a computer, as a data storage, as a superman. For them who uses, for them who doesn't use it, they doesn't know what you mean by cloud. So a cloud is something like that. For them who use, or don't use, they don't know what is you mean by cloud. For all the above who uses this one, and it is nothing but a lot of storage, compute cycle nearby. So cloud is nothing but a lot of storage. And what are the definition of cloud? If you go through that definition of cloud, uh, uh, is- it is a lot of storage available at a remote location. You can able to access that, or you can able to retrieve that data with the help of internet. So the term cloud, when we go up to this one, cloud computing is a remote location. If you say a remote location rather than reside in the own desktop and laptop device and other. Cloud computing is the catchword. If you say it, what actually does it? Everybody says it. Somebody says that cloud computing is something like that, which the data is storage somewhere down the line, which we don't know it, and we can able to access that data. How you are going to access that data? Through internet, in and out. If you have internet connection, internet connectivity, you can able to access that data irrespective of the time, irrespective of the location and everything. You can able to access that data. We are going to see some practical also, like load balancing and other things, which I've already told you. I can able to show you up how it is being told and how it is being done. So actually what I can say is that nothing but cloud, remote location, plus lot of storage, can able to access through internet. So if you don't have internet, you're not going to access that data, or you don't have, if you have an internet provided, you must have a login also. That we are going to see in the security process. This is what the definition of cloud. Now if you see this one, the journey of computers or something like that, the first data center was developed in 1940. This was the data center. The first data center was there from 1940 to 1950, or you can add 58. The next data center was from 60 to 78 or 79. Time sharing data processing industry was there from 60 to this type. Time sharing and data processing was there from 60 to 78. Then PC was there from 1980 to 84, but it was not distributed. Then came the grid computing from 80s till 2010 or something. It's still going on. Then after that, the cluster computing came up. But from 2000, we have got cloud and their data centers, as well as we have got peer-to-peer system. So if you say is that first data center was available from 1940 to 60, then the time sharing system came into existing from 60 to 80. We can able to tell in that from 82 or 84 we got a PC which was there, and then from 80 to 2000 we have got peer-to-peer what do you call peer-to-peer system, grid system. There are different what you call technologies came into existence. First was peer-to-peer. Next one is grid computing. The third one is cloud cluster. Then came cloud and data center. So if you see the history from 1942 to 2012, uh, we have seen a lot of changes. Data centers, first data centers to cloud data center, where data center was located at particular location and they have to work on this one in 1940s or till 1980s or something like that. But now, if you see, we don't know where the data center is located, where they are located, and how they are stored and everything. Now, next move on to other. What you call is that we call it the cycle of computers or something like that. First, where we have a terminal and mainframe. We used to store the data in this one. We used it to operate and we used to store the data. Then we got a PC with your hard disk and everything. With your hard disk and everything, you can see the diagram of this one, how it is there. Fine. So first we have got a terminal without any hard disk or something like that. When we got a PC with RAM, hard disk and everything. Then we got network computers. We can able to connect with all the PCs. Then we can able to connect PCs, internet connection, PC with the laptop and other things. Then we got a grid computing. We are going to see what you mean by grid computing. Then we have got cloud computing. What is actually the user is there, laptop is there, and they're able to connect the cloud computing. We don't know what will be the next step here. So if you see this, can able to see this is called internet. So you can able to get in touch with cloud computing with the help of an internet. And more important, this is stage one. If you say this is stage two, this is stage three, this is stage four, this is stage five, this is stage six. So if you discuss it, there are about six stages which we are going to discuss. It. First one is a terminal with mini frames where there is no hard disk or something like that. Then we come to the user PC where we have a hard disk as well as RAM stored. Then third, we have seen a PC with users connected network. Then we have got PCs and laptop connected to the internet. Then we have got a grid computing. Then we have got a cloud computing. They can able to get this. This is the storage, cloud storage or cloud data storage. We can call it. They can able to get in touch with this cloud computing. And the next topic is called distributed system. What is distributed system? Distributed system is something like that, which give the concept of client and server. At any given time, somebody can be a client. At any given time, somebody can be a server. So if I take this as one system, if no, only client, sorry, client and server. It gave a concept of client and server, then peer-to-peer network. A distributed system give a concept of two things, what is called client server as well as peer-to-peer. What is client? Client will able to request the server and then reply. At this client able to request the server and it able to reply. This client able to send a request and at any client at any given time, one client can able to access the server. The next they have to wait it. Then the concept of distributed system came into peer-to-peer. What do you mean by peer-to-peer? At any given time, anybody can be client and anybody can be server. So if I want to ask a query somewhere down the line, I can able to ask him. So this becomes client. This person is asking the request, and this becomes server, which gives a reply. So it doesn't mean that if anybody about 30 system, it doesn't mean I need to go to the server. 29 can able to ask the question to 24, and 24, if that request is service is available, it will give reply to 27 29th. So in P2P network, what is the important thing is that at any given time, anybody can able to become a server and anybody can able to become a client. Whereas in client and servers, there is a one server, the number of clients are more. So once the client at any given time, only one client can able to access the server. There are other topics they have developed servers with many number of clients can able to access that we are not going to see that one. Okay, this is the topic what we have seen. And the next one is that properties of fault tolerance. What are the properties? Fault tolerance. What do you mean by fault tolerance? At any given time, if one of the system get fails, we can able to there is no problem. We are able to see there's no work, don't need to check the status of the node. The system can able to work out. If you go back, if at any given time if this client goes up, there is no issue. This part is working. At any given time, if this client goes wrong, this is working, this is working, this is working, this is working, this is for, and we can able to shift. If one or some of the node fail, the whole system can still work. Need to check the status of the node at any given time. If any of the node fails, that doesn't mean the network is still working. Each system has only limited incomplete view of the system. The computer may only know the one part of the input. Yes, there are some systems that they are only limited few replies. Let's take an example. If you go to the bank, you go to the cashier, he can able to just deposit the money. And if you go to the other side of the bank where you want to see the statement, there is only one person who can able to see the statement for other things. So here also, in each of the system has a limited incomplete view, and for what purpose it is made, it can able to give you the reply. That's all. Each computer share, yes, storage and everything. They can store the computer power as well as storage resources. Dispatch several tasks for each node. Yes, there are dispatch several tasks for the each node. Each node can able to do the different tasks at different times. So the major properties of this one is fault tolerance, which is very important. If any of the node gets by chance destroyed or something like that, that still the network works. And limited resources, each can able to the view of, let's take example, if I am the person who can able to correct the paper, I can only correct the paper, I cannot enter the marks, somebody else has to enter the marks. So each user share the memory and other things with that system. There are four properties. Now let's move on to this one, grid computing, ability to combine resources from different organizations for common goal. There are different computers which combine together to produce a goal. The user has to get the user of the grid appearance, as long as a big machine which can handle different jobs. Traditionally, grid is a physically separated machine. Traditionally, grid is a physically separated machine which are connected through logically. Physically means this system maybe somewhere down the line we don't know this system. Maybe let's take an example. This is in Hyderabad. This is in Chennai. This is in Bangalore. This is in Delhi. This is in Bombay. This is Mumbai. This is in Raipur. This is in Chhattisgarh. This is in Chhattisgarh. This is in Nagpur, and this always what do you call Gujarat. So these are differently, they're physically separated, but they are logically connected. The application of grid run logically share the environment. Each system will run that software. They are logically interconnected with different location. That software. So in a grid computer, a logical software runs on them, which connect with together all the system. They break the task, they manage the task, different parts, and they distribute the task and run for a common goal. So if I have a job of 10 jobs, so each system will look at 1, 2, 3, 6, 7, 8. So let's take an example. One system got two, another got one, 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 one. All the systems have got all the resources. They are distributed. They go for the common goal and they produce that. For an example, let's take an example which I say it, which we go through it. We have got a system. Unfortunately, all we have got labs. The labs we have got 30 systems which are available. 30 systems which are available. Sorry, there are 30 systems which are available. We have classes which are running from 9:30 to 4:30. What happens after 4:30? These systems are sitting idle. So what we will do, I'll use that system with a power backup, with software install them, I'll on them, and I'll put a person to work on them for all 30 system, one system. He will manage that 30 system. If I have got i7 or i9 processor, which are very fast and everything, that 30 system I combine to produce a goal. This is one ISL engineering college, one lab. Like that, there are different engineering college labs which can be used for grid computing to make it as a supercomputer and work for it. This is what a grid computing which work on. The next topic, as I told you, it's very what you call. I have already made this one. Why it is not coming? Found is very less. I'll make it to grid computing. Properties of grid computing. Different type of grid computing. I'll just modify this one. The found last time there was a problem with this one, and you can able to see this one. different type of grid. 14. Now you can able to see that one, and this is 14. Yes. Okay. Grid computing, data grid. It provides infrastructure to support data storage, data discovery, and data handling, data publication, and data manipulation. Means it is a data grid computing which store the storage data, data discovery, and other things which is there. Data center, we can call it as a data grid, where data is stored in that one, data is discovered, data is handled, data is publication is there. Collaborative they promote interoperability upon different organizations. Let's take an example. If I have got ISL engineering college or different colleges, ISL engineering college which have got different colleges, engineering college, degree college, and everything. All this data into ISL engineering college, one grade, B.Ed engineering college, one grade, and degree college, one grade. They all collaborate together for a different part, but all the data is available. Promote for interoperating operability among various organizations collaborating together for new same work, the same work, like you have got all the data is available for engineering college, degree college. What for what purpose that data is used? In order to know that the student is regular, in order to know the collection of fees, in order to give all the data to university, all these process are there for that purposes. So we are using that all the data, collaborating all the data, all the grid, and to produce it at any given time, I can able to access that grid from somewhere down the line. Now next one, utility grid. This ultimate form of which not only use the data, this is the utility form of grid in which not only the data is computed, cycle are shared, but the resources are also shared. Means the software, there is a utility grid where the software is already there, and you can able to use that software to compute the different values, to calculate the different values. You can able to use that grid, whereas here data is there, you can use for publish, whereas here the software is there, you can able to use that software to compute some values, to calculate some values or something like that. Then we have got entrepreneurs group. Then we have got this one. Grid is one of the established enterprise, big enterprise grid for different organizations. For example, we have got software, Facebook, Google, and everything. Google have got data center of the big organization, enterprise, that Reliance and everything function among their own things. How the different works are going on. This is something about different type of grid computing. There are different type of grid which we can call it as view. Uh, this is called data grid, collaborative grid, utility grid, enterprise, four types of grid. Then we have got cluster grid. This diagram you cannot able to see it. Let me go to it close to all. What do you mean by cluster group? Cluster computing refers to many computers. For an example, let's take an example. I'll draw a figure here. Review. Let's take an example. Cluster computing. We have got a. These are about 1, 2, 3, 4. This is fourth year A, fourth year B, third year A, and the third year B classes. For an example, if one roll number comes up, for an example, let's take example 121 or 81. Let's take example 17 batch 81. Come down, 17 batch 81 is available. It's not available. 17 batch 81 available. Yes, it is available. I'll get the data. So what happened? Now let's go other one. I'll go for B section. 18 batch something about 21. 18 batch 21 not available. 18 batch 21 not available. 18 batch 21. 18 batch 121. Sorry, it is not available. It is all. So I'm just coming up and checking this one. I'm just coming up, checking up this one. We are going to just for some 81. I just came down here. I just asked 81 is available. No. 81 is available. Yes, I'll get to say cluster computing is nothing but where this is your what you call data center. where one system, this is 4A, this is 4B, this is 3A. I'll come and ask, it's available 81? No, it's not available. So I'm not going and checking what are the different parts of it. Cluster computing refer to that computer that many computers are connected in a network, and the performance key is a single entry. Each computer that is connected to the network is called node. Fine, this is called node. The process of termination is that based on the principle of distributed system, you come and ask that data is available for you. Yes, it's available. Fine, I'll get you. If that data is not available, I'll move on to the next cluster and I'll ask that. So if in a cluster, if I have got, let's take an example, there are about 1 GB or 1 TB of data is there. I want to search that. That will be very difficult for me. So in each cluster, each node, I'll go and ask this data is available for you on a key process which are there. No, the data is not available. I'll move on to the next class. The same way as the roll number. If I tell you of 16 batch, 17 batch 81, which is available in B section, I just go and ask 14A, 4A, it's not available. I'll just go there, and 4B, I'll ask, yes, data is available. I'll get that data. And then I'll ask, what is your roll number? Where do you stay? And all this one in 4B. Whereas 3A and 3B, if I give 121, 18 batch 121, it's in 3B. So I'll ask 4A, it's not there. 4B is not there. 3A is not there. I'll go to 4B and I'll ask them, this is the what I'm going to get it. This is cluster computing, and each computer is known as a node, and where we have got a reference keys available on the node, we are going to check that one. If it is available, we are going to see that one. Otherwise, we are going to move to the next part. So type of cluster, I'll just what do you call, I'll update the found type of cluster, which is already there, 14. Yes, you can able to see it. Load balancing here also. Here load balancing a distributed, which are, if at any given time, if one of the node code are destroyed, we can able to run the network. There is no availability, high availability and load balancing. High availability, yes, there are number of nodes available to us. Yes, there are number of nodes available. High availability data storage is abundant. You can able to store the data at any of the nodes. Availability is there, and load balancing is also there. We cannot, let's take example node 1, node 2. For an example, let's take example, I have got node 1, node 2. Node 1 is fully occupied, and still I want to distribute or put a data in a node 1. It is not going to possible. I have to go, and the cluster will do it. It has to store in node B. So there is load balancing, and balancing combination will be there, and parallel processing of data is there. Like there are about 8 queries. Remember, if I can, let's take example, 81 has gone to 4B, then I'll ask for 121, then I'll ask for 32, then there are about 8 queries I've put out. 8 queries are simultaneously run, and simultaneously they are giving me process. So the parallel process will be very fast. So in a cluster, I just go out, if that is available, please give me the data. So I can put number of queries there, and I can able to get the data based on that one. This is what the cluster things are there. Now, cloud computing. There are, what do you mean by, as I've already told you, cloud computing? Cloud computing, which are already there. I'll just move the format. It is 14. Yes, it is now 14. Cloud computing, public cloud. If you say we have divided that into cloud computing is only possible. Is it only possible if you have a network? Possible. There are different type of cloud. What is that? One is public cloud, that's private cloud, community cloud, and hybrid cloud. Public cloud, anybody can able to use it, anybody can able to use it. Here the infrastructure is accessible to the public, and it's owned by the vendor who offer the services for cloud. For example, we have got Google. Private, no, you cannot. For an organization, you cannot do private cloud for FB, Facebook, or for Salesforce, for others. Okay, and community cloud, different names suggest jointly by the organization. There are many same name organization available, and everybody can for the community purposes. Like we have got a duplicate, sorry, similar name, duplicate names will be there. and customer base requirement based on the policies of, like, if you go for public cloud, what are the policies for filing an income tax? There is a different cloud available for it. What are the policies, how we are going to register the organization? There is a different cloud available, there are the links available, there are a number of clouds available for it. So that is based on the community needed. This is one community cloud. Then there are other one hybrid cloud, combination of private. This is a combination of three clouds: public, private, and community. The hybrid cloud is complex compared to other three, owning of owning to the execution and the management involvement. Why? Because it is a combination of this. So there are what you call rules that need to be followed. There are something which need to be followed. So we are going to see something about public cloud, private cloud, community cloud, hybrid cloud. So public cloud infrastructure is available, public can be used. Example, Google. Private cloud infrastructure is used by private vendor itself, and it's called Salesforce. Community cloud, which you can use for community, which can able to use for their own purposes. And not many can use this. Google can be used for everybody, but if you want to file internet, there is a problem. There is a things which can able to see it. Hybrid class with combination of all those things which we seen it. I'll stop here. Let's see how things are work out in my next class. Thank you very much.